Hi together, welcome to today's webinar hosted by the Open Telecom Cloud community. Today I have a guest here with me, it's Tino Fenle. Hi Tino.
Good morning, everybody.
And Tino will talk today about the topic WAF. What is WAF? It's the Web Application Firewall. As you can also see it here already at the slides, you will get some really cool insights. We have a nice live demo for you. And yeah, so it will be a really great webinar. So that's all from my end. So then I will lead over to you, Tino. Thank you for having you here and have fun all together.
Thanks. Yeah, thanks for the opportunity to be here. Good morning again, everybody. I hope you had time to grab a coffee beforehand. So now you can kind of sit back and relax and enjoy the session. This session is about insights into the WAF, like Stefan said. So it's the Web Application Firewall. And today's session is all about the WAF. What do we talk about today? It's first of all, we are talking about overview of the WAF. So what is it? Why do you need it? What are the benefits? Then as a second part, the protection features the WAF is providing. As a third part, this is the most time-consuming part, let's say. It's a live demo, so we are setting up a simple web server and also a WAF and see how it works in real life. Afterwards, I will talk shortly about the limitations and last but not least about pricing of the WAF. So I would say, let's start. We will start with the overview of the Web Application Firewall. Just as a brief overview, what is it? The Web Application Firewall is a firewall you place in between your clients that are accessing your web applications. Your web applications could be like an enterprise portal, e-commerce, like a shop, a web shop, but also custom web applications you have developed. The benefits about the Web Application Firewall are that you have protection of your servers against the most common attacks and vulnerabilities. So the purpose of the WAF is to analyze all traffic which is coming from any clients, like here you see notebooks, desktops, tablets, etc. It doesn't matter which client. If they want to access your web server, you have a protection mechanism which you can place beforehand. The question you would ask is, why do you need such a thing? The most simple answer is also attackers like your web apps. So that means basically for, let's say historical data breaches like successful attacks on web applications involved web applications like 48% 2 years ago. And also last year, it was again mentioned that web applications are the main attack vector for hacking actions. With over 80% of breaches. So this also symbolizes that web applications are also a vulnerability inside your structure and they need protection. Also important to know, when breaches are occurring, they have price tags, meaning, of course, you have, let's say, the data privacy issues, but also reputation issues. The median for an impact was $20,001, but could be up to almost $1 million of impact you have. And this is a really high price tag for a breach, which you, of course, want to avoid. So let's start with the highlights of our OTC Web Application Firewall. We have an automated attack detection. We have a management dashboard for alerts and controls. This one you will then also see in the live demo. You can create custom policies for specific use cases. And the WAF is supporting the threats against the OWASP top 10. For the OWASP top 10, I will just go into it later. The same is also for virtual patching. And last but not least, it is pay-per-use, like you would expect from a cloud service. You pay per hour. I mentioned OWASP Top 10. What is this? The OWASP Top 10 is a non-profit organization called Open Web Application Security Project. This is basically a community which is combining or summarizing the top 10 threats for web applications. And these are the most important topics you should focus on when you want to secure your web application. Important points for the Web Application Firewall are, of course, injections and server-side request forgery. Injections have been on top 1 for most of the time. They are now number 3, but still it's a really important topic to be covered. And this is where the Web Application Firewall comes into place. As the next one, I talked about virtual patching. What does this mean? This means generally when you have a vulnerability on the wide, let's say Log4j, which was just a recent or is a recent vulnerability, the average time you have about fixing this vulnerability in a, let's say, classic way, like patching and testing every single web application, is about 200 days. So this is a long time. You see here below a timeline about how long the application is vulnerable, and when it would be protected means you have fixed every single web application. With virtual patching, you can speed up this process, because when you use our WAF from the OTC, we have standard patterns, means we have standard protection mechanisms like the basic web protection, which I will explain soon. And this one contains a standard rule set. This rule set will be maintained by us, by the Open Telecom Cloud, for free with no additional cost. You have no maintenance window for your application, but you have the huge advantage that you can have your web applications protected in a really quicker time, because you don't need to take action. We will do it for you, and also we have a bit more manpower and therefore speed behind it. Regarding how the structure of the WAF is, basically the WAF considers traffic as either, let's say, regular traffic, which is the full line, or malicious traffic, which is the dotted line. And when the user wants to access web services, like a news site or a financial portal, whatever you name it, the WAF application is analyzing the traffic. You see in green the user. This is a legit traffic, meaning the WAF identifies, okay, this traffic is good, and will forward it to the web services. On the other side, you have like a malicious competitor who wants to crawl your website, but also a hacker which wants to attack you, wants to hack you with XSS, so it's a cross-site scripting, or with SQL injections. And this traffic is identified by the WAF and will be filtered out. Means it will just be dropped and will never reach the web server. One hint on this side, crawler is not always malicious. Crawler can also be wanted or positive, so this is something you can also enable on the WAF. For example, if you want to allow the Google bot to crawl your website, to have it appearing on the Google search results. Then next point is regarding the traffic. How does it work? In the standard way, you have your client who wants to access the web server. In this case, it's just example.com. And it is asking the DNS server what is the IP address behind this. And the DNS server will result the IP address, like in this case, this 80.158xx. When you implement the Web Application Firewall, you need to adapt the traffic flow, meaning you need to create a CNAME record in your DNS server, which is pointing to a custom URL you will get from us. It's something cryptical, and then otcwaf.com to forward the traffic from the DNS server, not directly to the web server, but firstly to the WAF. The WAF then has two engines, which I explain later, a custom and a semantic engine, and is analyzing the traffic. And if the traffic is considered legit, it will be forwarded to the web server. Otherwise, as explained, it will be dropped. The WAF application firewall is one part of the general security structure. For example, the zero trust model. This means in your architecture, usually you have the anti-DDoS also as a combination with the WAF together as a, let's say, gatekeeper before you have traffic inside your workload, meaning for this architecture, you have a public IP, which is protected via anti-DDoS as a standard with OTC. This is a service you have for free, and this is included with Elastic IP. And you can also use WAF for protection of this one. And that is your gatekeeper you would use as a entry gate. And then later on, you of course have additional protection mechanism, like you can implement a load balancer for high redundancy, for high availability and redundancy, but also subnets regarding which web server can reach which application server. So you would usually use subnets to minimize the access to the servers. But this one is not part of the WAF. It's just to mention that WAF is one big part of the puzzle to implement a secure architecture. Now coming a bit more into the detail about which protection features the WAF is offering. For that one, I will just give you a brief example about how an attack would look like. For example, we have a hacker here who wants to just place a simple SQL injection. So he's opening the login page and entering just a simple syntax like ID equals 5 or 1 equals 1. This is just a simple test if this one will be forwarded and if the web server would be vulnerable to SQL injections. Then it will pass the Web Application Firewall. For that one, the Web Application Firewall has two different engines. First of all, it has the regular engine. This is blocking requests with an accurate matching attack. So if you create a custom policy or a custom protection mechanism, it will compare if this one is matching. For this case, it will not apply because for SQL injections, this is just one example. There are basically endless examples how an SQL attack could look like. So this is nothing you can or you will create manually. So this is included in our basic rule set for SQL injection protection. And also it is something you have not as a static match you will have, but more like a semantic to identify that this one is SQL injection. Therefore, we have a semantic engine behind that. It's kind of artificial intelligence to detect, for example, this SQL injection, but also cross-site scripting attacks, for example, to protect the web server from that one. This whole procedure of protecting your web application for or against attacks, is a built-in detection process. So you don't need to act. So this is all happening in the back end. And with these two engines, we reduce false positives and false negatives to just block the traffic which is malicious, not to block, let's say, good traffic or to allow bad traffic. Having this one explained, I will now go into the protection features which are available on the Web Application Firewall. And this is divided into 5 categories: basic web protection, CC, so challenge collapser attack protection, precise protection, web tamper protection, and IP blacklist or whitelist. Let me just briefly talk about the basic web protection. The basic web protection is a basic rule set of protection rules, which are just summarized together as these are the most common attack patterns which are happening. And therefore, these kind of attacks are included. I will not explain every attack, how it works in detail, because this would take a lot of time. Therefore, I will just show these are the most common ones, which are included in the basic web protection and which will be handled by the Web Application Firewall. Then we have the challenge collapser attack protection. This is basically kind of anti-DDoS on HTTP level. This means you have, let's say, multiple requests reaching your web server, trying to create a denial of service, so a DOS, for your service. And this is an attack which the WAF can protect. As a default CC policy, it is implemented that when you have more than 500 requests within 5 seconds from the same IP address, requesting something from your web server, that this IP address is blocked. But this is something you can also configure with additional rules, meaning when you go into the settings, you can create a limit, for example, per path. So on the path on your web server, if it is considered per user or per IP address, what the rate limit is for blocking, how the block would look like a capture code, or if you create directly a blocking page for the customer, how long the customer would be blocked, and if the blockade page is customized. In the real life example, it would look like this one. So meaning you create, for example, a policy like if the user is creating a request in, let's say, two times in 2 seconds, because this would be your wait limit, and he just presses F5, F5, F5 to update the page. You would, for example, see this page as a default to have a block, and you get the ID, which you can later on see in your events to see what is happening and see the details of the event. Also, you can create a capture. So the user is displayed this page. When he clicks on this click here button, he will be displayed with some kind of symbols which he needs to enter, like a bot control, a capture code. You can imagine this one. Then we have the precise protection. For this one, you create the protection policies directly on the HTTP field. This means you can use, for example, the user agent field of the HTTP package to, for example, block specific devices or specific IPs or users coming in from a specific website. This is a referrer field in the HTTP package. And this one you can also specify, like how long should it be available, like a campaign, for example, for which path or from which website does the user come to directly block him. In the setting, it would look like this one. This is an example where I would like to block iPhones to access my web page. So I use the field user agent and I just include iPhone OS. This is something which is included in the HTTP package. And when now somebody from whoever location, doesn't matter, it is now content of the package, of the HTTP package. If iPhone OS would be content, the user is directly blocked and he could not access the page. The next one is the web tamper protection. This is a feature which is caching the web page, a static web page, from the web server directly on the WAF. This has two benefits. The first is that the WAF caching the website, meaning when the request is happening to the WAF, the web server is not contacted at all, meaning the WAF can directly respond. And this may reduce also the response time for the website. Also, the WAF is then checking the content on the actual web page if there have been some modifications or some malicious modification to check tampering. This one can be then updated, so the cache can be updated manually to reflect changes to the web page. Last but not least, we have a blacklist and a whitelist for IP addresses. This is how you would expect. You can enter either a single IP address or also an IP address range, like with the CIDR notification, like //24, to just block a whole IP address range. For the policies and the rules, also again, just the structure, how is it structured? We have on the bottom the WAF. So this is the whole tenant-wide settings for the WAF, where you set up or where you have the dashboard, you see the events and also the logging. This is something where we just will come to in the live demo. You have the domain. The domain is really the certificate and the protocols you apply to, like your page, where we come to. Above that, we have the policies. So the policies are containing the protection rules above and are tied to a domain. You can tie also one policy to two domains. This is also possible. So now we have the COE. As the next one, we want to do a live demo. For that one, I put up also some kind of agenda of what we do. We will create a simple web server. For that one, a big shout out to Uli. There's a hands-on training on the OTC community with a lot of examples. We will use the one for creating a simple web server. Then we will create a WAF domain. We already have a domain which we can configure. It's also a domain from Uli. So thank you, Uli, for that one. Then we will create a CNAME for the DNS to change the traffic flow to the WAF. Then we will set up notifications just to see how it looks like. Then we will create test entries, meaning we use the wafer, the WAF tester, to just put out some sample attacks on our web page and see how the notifications look like and also how the dashboard looks like. Later on, we will then also create a self-signed certificate to see how HTTPS on the WAF would look like. We will now go to our OTC domain. So now everything here is empty. I will firstly create a simple web server, which we want to protect. For that one, we have a tutorial by Uli in the OTC community. So I just use a simple server with the lowest specification. It's just a simple server. So we choose, for example, the latest Ubuntu version. Then we use our default VPC. Important for having access to the server is to create inbound rules for HTTP and HTTPS. For that one, we have a security group for the web server. Just for this demonstration purpose, and yeah, there are more ports open which you don't need, but more important are port 80 and 443 for HTTP and HTTPS. The server must be reachable from the internet, so we auto-assign an elastic IP. For logging in, we need a key pair, or already created one. In this demo, we will not log into the server at all, so this is not necessary. important one from the training session from Uli is he created a script on how to create the web server. So you can just download this one and open it. And basically this one is the cloud init configuration we need to paste here on advanced option. You can either upload as a file or just paste it here. This is basically just downloading a simple web page from OBS and also installing Apache. Now we set on confirm, create now, and the server is now being created. As the next one, we want to protect the server. Therefore, we need to create the WAF domain. For that one, we need to go to the WAF. And what we then will see, because we need to go back to the ECS, is while creating the domain, click on Web Application Firewall domain, you need to enter the domain name. That is something we have given by the domain we want to protect, but of course we need the IP address, a public IP address of the server, just for your information. That is something we of course get from the ECS, which we have now created. In the meanwhile, the public IP address should be available. Yep, it is here. Depending on the speed on the setup, the server should already be reachable. Not yet, so we will wait. So in the meantime, I can go to the WAF and create a domain with this IP address. We have given a domain which we want to protect. It's the waf.ulis-hands-on.de, and we just click on create. So this one has now been created. We look for the server if this one has been started. So yes, this is online. So this is the IP address on the server directly, which we now want to protect with the WAF. So now that we have created the WAF, we need to set the DNS entry. So here you get the important CNAME information, which you need to copy and to enter in your DNS provider as a CNAME for the host name here now is WAF. For that one, you get also then the IP addresses for restricting the access to the web server. In this case, we don't use it. So now we need to, like I said, to set the CNAME on the DNS server. We have it already configured here on the OTC, the DNS. If you have a different DNS provider, then of course you need to enter the CNAME on your provider. So for that one, I create a new record set. So it is waf.ulis-hands-on.de, and it is a CNAME. And this is the entry we just have received from the WAF. So we save this one. And now we go back to our WAF. And on domains, now we can click on the domain, just check if DNS is configured now. Now it is normal. This should mean if we now go to this domain name, we already have access to the server. So now we are routing the traffic not directly to the server, but it is filtered to the Web Application Firewall. You can already see the server is responding like the IP address is the domain name. So this one is working. But what we now want to do is also to test it, to, let's say, create some attacks. But first of all, we want to get notified when attacks are happening. For that one, we go to events and to notify, and you can have notifications based on notification topics. In this example, of course, we don't have anything because it's empty. WAF is integrated with SMN, so the simple message notification service. For that one, we now create a topic because we want to get notified about attacks. We just call it WAF demo. And for that one, we then need, of course, to add subscriptions. How do we want to get notified? In this one, I just want to get information via email. So I enter my email address. Now that I have entered my email address, there will be an email sent to that one because we need to confirm that we actually want to be a subscriber of that one. So this will come in now. So this looks like this one. we have subscribed to this one. Please confirm it. So I will now confirm it that we want to receive notifications. So this is successful. If we now refresh this one, now it is confirmed. So we will receive email addresses when the subscription is triggered. But what we need to do is also to set it up in the WAF. Now we go back to it and go to, domains. Notify, we want notified. Here the WAF demo is already set because it was the only one available. And now it is already active. This means if you want to, or if we get some events, they are sent to this notification topic, and behind the notification topic, we have our email address behind that. So we should receive notifications. What we now want to do is to create some test entries. For the test entries, I will use a third-party tool. It is called WAF. It's Web Application Firewall Tester. And for that one, I want to test my domain, which we now have, the WAF odyshands-on.de, and we want to evaluate it. For that one, to authenticate ourselves, we need to do some steps. I will just use the DNS record because it is our domain. So I will now present it with this text entry I need to add to our DNS to prove that this is my domain where I want to send a text to. Therefore, I go back to DNS. And I will create on this one a record set with this value I was just presented, and it should be a text. And it is cloudbricks.waf. Okay, so now we have set this DNS entry to prove that this domain is actually ours. So we have it checked. And now they are checking the web server. Here are some sample attacks which are sent to the WAF. Now that is already working, we can go back to our WAF, and we should already see entries. Here already we have 114 attacks which are happening. So this dashboard is filling, for example, with SQL injections, command injections. Yeah, the top 5 source IP addresses, yeah, we only have one because we have one central testing tool. But this is just for purpose to see how the dashboard will look like and also the events. So if we now go to events, we will now here see what is happening. For example, here's an attack. We have multiple attacks which are happening. We have now 296. For this one, you can see where it is coming from, to which domain, from which URL, what is the payload behind it, what kind of event type is it, what is happening. And you can also go into the details. Then you see the malicious load and also the request details for that one. The protective action of this one is currently log only because we did not configure anything. If you set up the WAF, you will be having a policy created automatically. This is a basic rule set with only the CC attack protection I mentioned, which is via default created. The basic web protection is set to log only. This is something you can configure to activate it, like to block, but also to set the protection level. This is a sensitivity level, meaning the lower the level, the more false positives, false negatives you have, and the higher the more false positives. For that one, you can like I said, enable or disable that one. For example, the crawlers, they are not active in default, and it's also log only, just to see what would happen. For that one, the WAF would identify these ones as an attack and would then, let's say, in real life, block the attacks to that one. The events then will also be saved as a CSV file once a day. They will then just be presented to be downloaded. For that one, you can then, for example, further process them, like import them in your SIEM. This one is also possible to access the events in real time via API if you want to forward them. The notification we already set up. This is what I have showed. Then we have the policies, like I explained. And as the next step, what we also want to do is, now that we have events and the dashboard, is also to see how it will look like, or what the additional settings are when we have HTTPS enabled. For that one, we have here domains. And for that one, you see the client protocol is only HTTP. That means all traffic coming to the web server is currently not encrypted. That is something we can change. For that one, we of course need a certificate, meaning when we now want to add that we also support HTTPS, we need to enter a certificate. A certificate we currently do not have, but what we can do is just create one. For that one, I will also go to a community entry we already have. It is about creating a self-signed certificate. For that one, it's basically just creating via OpenSSL a self-signed certificate, which you can just upload to test how HTTPS would look like. This one you would need to upload to the WAF, but also upload to the web server. And if it is self-signed, you would also need to add it to your trusted authorities. Otherwise, your browser will not trust it. But we will just upload it to the WAF in this case, just to see how the settings would look like. So we will not upload it to the web server, meaning HTTPS will only be at the WAF level, but not at the web server level. And also we will not import it into our trusted authority storage. This means we will expect to get this message that the connection is not secure because the certificate is not trusted. But either way, we will just see how it will work. For that one, I will use git bash to just use this command to create a certificate. Here I can just enter some dummy data, like Germany. Let's say we are in Düsseldorf. Organization name, OTC. The common name is the important one, which will be displayed on the certificate. So we use our FQDN, meaning waf.odyshands-on.de. Email address, doesn't matter, just something. And now we have created the certificates. So this one looks like we have a CRT and a key. And this one is the needed information we need to enter in our WAF to upload the certificate. So we go into certificate and upload certificate. We just call it WAF demo. And for that one, we need the certificate content and the private key. Here you see how it should look like: begin certificate, end certificate, and begin private key, or begin RSA private key and end RSE private key. The easiest one to obtain this one is just pasting that one into, or opening this one into Notepad++, for example. Then you see the content and can just copy paste it. So here we have the certificate, and here we have the key. And now we have uploaded a demo certificate. What we now need to do is we need to attach it to the domain that we allow HTTPS. So we go to it and go to edit server and change to HTTPS and upload the certificate. Now we have the WAF demo certificate. It is now attached to it. Now that we have HTTPS enabled, we are presented with two additional settings. So we can configure TLS for 1.1 or 1.2, and we can select different cipher suites, which are also mentioned below. We will just stay with the default cipher suite in this example and change to TLS 1.2. This now means we can access also the web server. Where did I put it? This one? No, it's the IP. Let me open this one via HTTPS. But of course, we expect to get this one. This is something we get because the certificate here is not secure, because it is not trusted. Website identity does not supply ownership information, So we have a certificate which should be working. So we can see the certificate, but we just accept it and go forward. And we can then also go to the web server. Let me just open Chrome for that example. Here you can see it better. That you can see here, certificate is not valid anymore, and you see it's not trustworthy because it's not in our space. But we could still go to the page. Now we have it. So we go to HTTPS to the WAF, but the WAF is then using the certificate to encrypt the traffic and now put the traffic unencrypted to the web server. In a real life example, you would of course then install also the certificate on the web server and configure Apache to use the web server, and also have a certificate board which is trusted by a root CR, like from where we sign or whatever. So then as a last thing, we have created some entries in our dashboard. So here you see the attacks and the types of attacks. Here you see the events. What I also wanted to say is for the notifications which we set up, so they are in the notify tab, we selected the WAF demo as a notification topic, and behind that we selected also the email address. Now that the attacks have been fulfilled, we now get a notification like in the last 5 minutes we received 146 attacks of this types, 119 attacks of this types, and so on, and also a link on how to see the attacks. So, but this link is just basically forwarding us to the dashboard, and then we can ourselves go to the events and see what is happening. Basically, this will now conclude our live demo to set up a web server and have the settings displayed. Just to sum up, what did we do? We created a simple web server with the training from Uli. We created a WAF domain with the domain we have. To set it up, we needed to set the CNAME on the DNS server created by the WAF. We also set up SMN notifications to see when attacks are happening. We created this one via email, but you can also create this via HTTP or HTTPS. In the future, it is also planned to support the endpoint for the OTC app, that you also get a push notification on your OTC application or on your app, on your mobile app, when there's an attack on the Web Application Firewall. We created some test entries with Wafer, the WAF tester, and then we rose through the dashboard what is possible to set up, how does it look like in real life. And also we created a self-signed test certificate for HTTPS and uploaded it also to the WAF to see the settings, what is possible with TLS to set up. Then we will come to the last 2 points, to the limitations we have with the WAF. First of all, the not so important one, let's say, we have soft quotas for domains and certificates. You can only create up to 100 domains and up to 100 rules to that one. I guess that is nothing you will come across because policies, I guess you need in real life 1 policy per domain and 1 certificate per domain. Therefore, 100 domains is really a high number which you should not reach in reality. At last, the protection of the IP address. You may have seen that the WAF was looking or was forwarded to a public IP address like Elastic IP address. Therefore, it is needed in the real life example to also limit the access to the web server which you want to protect, because the web server is still available under the public IP address. You would set up firewall rules to restrict the access to the IP addresses from the WAF, which were displayed in the setup, in the real life setup, in the demo setup, which we did not use. That is something you would implement on the firewall level. You also want to allow maybe traffic from your public IP address from your company, for example, for the VPN, to be able to maintain the server. Yes, as a last point, we have pricing. And for the pricing, like I said in the beginning, the pricing is pay per use, so you pay per hour and per requests. So let's start with the less important one. It's the request. it's paid per 1 million, meaning for 1 million requests to the WAF, you pay about 60 cents. That is, not really a high amount to be considered. The most important point is the domains. So the domains we set up. So we set up one domain, this WAF odhands.de. This is charged per hour, depending on how much domains you have in your tenant. Now we have one domain which is running. This would be running, let's say 24/7 would be 70-30 hours per month. Then we would pay 21 cents per hour for the domain. The more domains you have, the least expensive it will be. So the example would be you have 2 domains running 24/7, and for example 5 million requests to your web server. This would sum up to about 300 per month. So this would also conclude my presentation for today's webinar. I also put up some links for you to go to the community, also to the product side. We also have a Terraform provider for WAF, so you don't need to use the GUI. You can also have your Terraform provider to create the WAF as infrastructure as code. We also have an OTC community where this video will now be uploaded to have it later on available for you as a video on demand. And also we have a help center with a lot of content. Looking now at the questions, we have a few. Just let me read it. Let me start with one. Why does the web server need to have an elastic IP when we redirect the traffic to the WAF? That is something which I was explaining in the beginning. This is currently an architectural restriction, which will be solved with a new WAF version, which will come later. Currently, we have the restriction, like I mentioned in the limitation, that the WAF network-wise is in a different network. Therefore, it cannot reach the internal IP address of the web server and must be using the external IP address. Coming back to the questions, this would also be answer the second question: why do we need an EIP for the WAF in the first place? Because it's an architectural topic as of today. Then we have a second question: WAF works only against SQL injection, but not JavaScript injection. That is currently, yes, that is currently the fact. SQL injection is protected. JavaScript injection is currently not supported. Then we have a second question, or another question, when we will support HTTP2. HTTP2 is currently on our agenda, on our roadmap. We also consider this as a really important feature, but currently, as of today, we have no concrete date which I can give out to you.
Yes, hello, Nicola speaking here. One question, when is planned to implement TLS 1.3?
Yes, TLS 1.3 is also on our roadmap. Currently, it is planned to have it later this year.
Okay, thank you.
I have one more question in the chat from Michael Nick. Currently, WAF does not support geo-blocking. There is no plan to support it yet.
There is a plan to implement this feature for geo-blocking. This is also planned for Q3 together with TLS 1.3, that you, for example, just can block IP addresses from a whole country. As of today, you would need to identify the IP address ranges yourself and put them in the blacklist, but this feature is planned to be supported, yes.
Cool. So then I would say thank you a lot, Tino, for this great presentation. Thank you for this very quick answers also in the Q&A session now at the end. With this, I will say thank you also to everyone who joined today's live webinar here on the Friday. Wish you all a nice weekend and see you hopefully in the next webinar at the end of the next month. Thank you all. Wish you a nice weekend and bye. See you.
Yeah, thank you.
Bye. Thank you. Have a nice weekend.
Thank you. Bye.